Okay, so this again is my version of the 2006 question. It is using first principles to derive the answers to your parts. In the question for this, we'll always be looking for this, where we have .xH2O. It makes this not a primary standard because of the water of crystallization that is attached. So we will be, as always, just going through our first principles maths to find our big M concentration. So we always start off with moles in 1,000 centimeters cubed for our way in. When we go down in our W, we are always dividing. So we divide by 1,000 to find out what's in 1 centimeter cubed. When we go up, it's always a multiplication. So in this instance, we're multiplying by the titer volume. That will give us moles at our end point. We're then going to apply our ratio. And once we do that, we will find moles of the other reagent. And when we go down again, as we say, it's a division to tell us how many moles are in 1 centimeter cubed of our second reagent. And finally, we're going back up to finish it off. And we multiply it by 1,000 to find how many moles in 1,000 centimeters cubed. We will be using our mass triangle to find our grams per litre. And this question, because of the XH2O, we will have to calculate a percentage of water, and we will have to work out the value of X in the XH2O. So first thing we always do is we say attic and basement, and when we look at the basement, we're trying to find a whole number that could be measured out using a pipette. And if we read across this line, we have 25 centimeters cubed of this solution. So we just have a read back, and this 25 centimeter cubed refers to this here. So in my basement, we have sodium carbonate. So when we titrate, it's just going to be the sodium carbonate, not the water of crystallization attached. So that must mean in my attic, I have HCl. So we have a read through, and we now know my volume here is 25. Down here, I have 0.11 big M of my HCl. My average volume of my hydrochloric acid is 26.05. My ratio from my equation is a 2, and for the sodium carbonate, it is a 1. This has to be my question mark, and just to confirm it, I read down through my question, and it says find the concentration of sodium carbonate, so that is correct. We also want to see, is there any extra information in the question? So I am looking now up here, and this is my extra info, 8.2 grams of my sodium carbonate in 500 centimeters cubed. So 8.2 grams per 500. I personally always put that into grams per litre, because when I have my titration grams per litre, the units need to be comparable. So this is my way in. Always start by telling what 0.11 big M means. It means 0.11 moles in 1,000 centimeters cubed. This is this point of our W. So the first instruction is we're going to divide 0.11 by 1,000. So when we do that, we're going to get 1.1 by 10 to the minus 4 moles, and that's in a centimeter cubed. So that's brought us to this part of our W. We're going up, so we multiply by its titer volume, which in this case is 26.05. And when I do that, I get 2.87 by 10 to the minus 3 moles. And that is in 26.05 centimeters cubed. So this is our first titer volume. So we're now up to this part of our W. We then are going to apply our ratio, and our ratio is 2:1. So 2.87 by 10 to the minus 3. We divide it by 2, multiply it by 1. And when we do that, we get 1.43 moles. 1.43 by 10 to the minus 3 moles. And that now is going to be in the 25 centimeters cubed. So this is my second titer volume. It's brought us to this part of our W. We then are going down, so we're going to divide 1.43 by 10 to the minus 3. We're going to divide it by 25. I don't have a calculator, so I apologize for that. If we did that, it would have brought us to this bottom part of our W, and our last step would have been to multiply by 1,000. So I'm just going to do those two steps together. And when I do that, I get 0.0573 big M. Okay, this is to 4 significant figures, so I've just added in my extra 4 or the extra 0 because it is significant. We always then say we turn our moles into grams per litre, so it's going to be N by molar mass, so 0.05730. We know sodium carbonate, we have to calculate its molar mass, so it's 23 by 2, 12, and 16 by 3, and when I add all those up together, 106. So we always show all of our workings out for our examiner, and when I do that, I'm going to get 6.07 grams in a litre. So we've done our W. I should have said this 0.05 was to get to that was that little part on the top. So I've always said do your W, do your grams per litre, and then have a peek at the question. So it is saying in C, the number of moles of hydrochloric acid per centimetre cubed and per 2605. If you can annotate, annotate. If you can't, don't stress about it. But this would be the answer to C part 1, and this is the second part to C part 1. It then asks the number of moles of sodium carbonate which reacted with our HCl, so that's using our ratio and applying that. So this is the moles of sodium carbonate, so that's C part 2. Our next bit down here asked in D the concentration in terms of moles per litre, so this is going to be D part 1. And then finally it asks grams per litre, and this is going to be our D part 2. So if you can annotate, great. If you can't, don't stress. So the last part in E, we have to calculate the percentage of water of crystallization and the value of X. So this is how I set it up. Na2CO3.XH2O. So what are the pieces of information we have? We know from our extra info that in this case we had 16.4 grams in a litre. We know from our titration that we had 6.07 grams in a litre. To figure out how much water I have, I'm just going to subtract one from the other. So it is going to be 16.4 subtract 6.07. And when I do that, I am going to get 10.33 grams in a litre. Okay, so again, the error that gets made is the units for this are wrong. You would have just used the 8.2 grams and 250, and suddenly your maths is not making any sense. Or it will make sense because you'll be taking 6.07 away from 8.2, so that will make sense, but you will lose a mark for not having the right units at that point. Okay, so to figure out percentage of water, we need to work out our grams of water, and we're going to put that over our grams of our total, and we're going to multiply it by 100 over 1. So when we do this, we're getting 10.33. We're dividing it by our 16.4 and multiplying it by 100 over 1. And when we do that, we're going to get 63.0%. So that's my first part of E. The next thing we have to do is work out our value of X. So to do this, we're going to do empirical formula. So to remind you for that, we find moles for everything we're interested in, and we're going to divide by the smallest number when we are ready. When we introduced empirical formula in stoichiometry, we were doing it for elements. Now we're going to do it on compounds. So what's the information we have? We have 6.07 grams in a litre. We're going to divide that by its molar mass to find the moles. And when we do, we're going to get 0.573 in terms of our moles. And if you look here, we've essentially just gone backwards in this calculation. In terms of then our water, we are going to be going 10.33. Show our calculation for water. So it's going to be divided by 18, and when I do that, I'm going to get 0.337. So when we have a look at the two numbers, this is the smallest number. So the rule is you divide everything by the smallest number. So divide it by itself. That will give us a answer of 1, and that makes sense because we should only have 1 sodium carbonate present in our formula. And We divide 0.337 by 0.573, and when we do that, we get 5.88, which is as good as saying 1 is to 6. So in this case, x is 6. So Na2CO3.6H2O is what will be written on the pot. But if you're annotating your answer, this is the answer to E.